So maxima and minima. முன்னாடி நம்ம சின்ன கிளாஸ்ல படிச்சிருக்கோம் the concept of maxima minimum of function of one variable. So for example y equal to f of x, right? So it is a function. How can you find out the maximum value and minimum value of this function? What do you mean by maximum value and minimum value? So for example, you take it as a y equal to sin x, right? The graph of this sin x is 1. Even graph of the sin x. The sin x order maximum value, minimum value, and the maximum value 1, the minimum value minus 1. இல்லையா இதான் 1 நமக்கு இது minus 1. இப்போ இது 0. எப்போ maximum value கிடைக்கும் 5/2. இது வந்து 5. இது 3/2. இப்போ இந்த maximum value எங்க கிடைக்குது பாரு. At x equal to 5/2 the function has the maximum value 1. And x equal to 3/2 the function has the minimum value minus 1. And again x equal to 5/2 the function has the maximum value 1. Right, it goes on. So that means while the function has only one maximum value, but it happens at the different times, different places. Okay, x equal to 5/2, x equal to 5/2. So in the point la namakku enna kedikudhu maximum value kedikudhu. So இதான் நம்ம சொல்றோம். இப்போ இது எப்படி நம்ம கால்குலேட் பண்ண போறோம்? கிராஃப் எல்லா ப்ராப்ளத்தையும் கிராஃப் போட்டு மைனூட்டி பண்ண முடியாது இல்லையா? எல்லா ப்ராப்ளத்தையும் கிராஃப் போட்டு மேக்ஸிமம் வேல்யூ எங்க இருக்கு, மினிமம் வேல்யூ எங்க, ரொம்ப டிஃபிகல்ட்டான டாஸ்க். இப்போ என்ன ப்ரொசீஜர் நம்ம பார்த்துருக்கோம்? dy/dx கண்டுபிடிப்போம். Then d²y/dx squared. Then after that you put dy/dx equal to 0. You find out the points. You substitute in this. If it is less than 0, maximum at that point. If it is greater than 0, so minimum at that point. அப்படின்னு முன்னாடியே நம்ம பார்த்துருக்கோம். அது வந்து அது ஃபங்க்ஷன் ஆஃப் ஒன் வேரியபிள். ஸோ நம்ம இங்கே என்ன பார்க்க போறோம்னா மேக்ஸிமம் அண்ட் மினிமம் ஆஃப் ஃபங்க்ஷன் ஆஃப் டூ வேரியபிள். மினிமம் வேல்யூ ஆஃப் ஃபங்க்ஷன்ஸ் ஆஃப் டூ வேரியபிள். இப்போ இங்கே நமக்கு என்ன வரும் அப்படின்னா இன்னும் ஒர்க்கிங் ரூல் நமக்கு வாட் பி த ஒர்க்கிங் ப்ரொசீஜர் ஆர் ஒர்க்கிங் ரூல். The first step, we find out the first order derivative, dou f by y. Suppose for example, let f be a function of two variable f and x and y. The working rule, the first step you find out dou f by dou x and dou f by dou y, and then dou squared f by dou x squared and dou squared f by dou x dou y. Then dou squared f by dou y squared. The first step in the first order derivative and second order derivative calculate pannu. Now the second step, put f dou f by dou x equal to 0 and dou f by dou y equal to 0. இப்போ இந்த ரெண்டு ஈக்குவேஷன் நம்ம சால்வ் பண்ணா நமக்கு ஒரு பாயிண்ட்ஸ் கிடைக்கும். இந்த மாதிரி a, b, C, D, etc. So இந்த பாயிண்ட்ஸ்க்கெல்லாம் பேர் என்ன? ஸ்டேஷனரி பாயிண்ட்ஸ் அப்படின்னு சொல்றோம். So that is the second step. First step we find out the derivatives. The second step put the first order derivative equal to 0. By solving these two equations you may get the points a, b and C, D, etc. These points are called stationary points. Now the third step, compute delta. The delta is nothing but RT minus S squared. இப்போ ஆறுங்கிறது என்னது? ஆறுங்கிறது என்னன்னா dou squared f by dou x squared, and S is nothing but dou squared f by dou x dou y, and T is nothing but dou squared f by dou y squared. இந்த டெல்டாவோட வேல்யூ கால்குலேட் பண்ணோம், right? After that you go for a cases, right? So at a point, take a particular point a, b. So in the point எடுத்துக்கலாம். So we have to calculate delta. So if delta is greater than 0 and r is less than 0 at the point a, b, right? if delta greater than 0 and r less than 0 at this point a comma b, then we say that then the function has a maximum value at this point a comma b, right? If delta greater than 0 and r is less than 0 at the point a comma b, then the function has a maximum value at this point. The maximum value வேணும் அப்படினா you substitute this point in this given function, you may get the maximum value, right? The second one, if delta greater than 0 and r is greater than 0 is at the same point, if it is, or you take another point c comma d, or you take the same point a comma b. இது எக்ஸாம்பிளுக்காக கொடுத்துருக்கேன் a comma b ன்னு இன்னொரு பாயிண்டா இருக்கலாம். இந்த பாயிண்ட்ல மேக்ஸிமம் வேல்யூ கிடைச்சிச்சுன்னா இந்த பாயிண்ட்ல மினிமம் வேல்யூ நமக்கு கிடைக்காது ஆப்வியஸா இல்லையா. அதனால வேற ஒரு பாயிண்ட் எடுத்துக்க நீ c comma d. So then the function has a minimum value at the point c comma d. The delta greater than 0 and r is greater than 0, the function has the minimum value at the point c comma d. Minimum value வேணும் அப்படினா you substitute this c comma d in this given function, right? The third case, if delta less than or less than 0, if delta less than 0, then the function has neither maximum nor minimum. So neither maximum nor minimum. ஆனா அந்த பாயிண்ட்ல வந்து மேக்ஸிமம் வேல்யூவும் இருக்காது மினிமம் வேல்யூவும் இருக்காது. That means neither maximum nor minimum at the point when the delta is less than 0. The fourth point, if delta equal to 0, I know the case is doubtful. That means the further investigation is needed for identifying the extreme values. That is the fourth case, right? So these are all the four cases. This is the working rule for finding the extreme values. Sometimes we find the maximum value or minimum value are called extreme values, either maximum or minimum values, right? Okay. Do one problem so then you can understand this idea. Go on the problem. Examine f of x comma y equal x cube 3xy square minus 15x squared minus 15y squared plus 72x for extreme values. So extreme values அப்படினா maximum value or minimum value. அது நான் செக் பண்ணனும். என்ன ப்ரொசீஜர் சொல்லிருக்கேன் முன்னாடி? First you go for a first order and second order derivatives, partial derivatives. So you take f equal x cube plus 3xy squared minus 15x squared minus 15y squared plus 72x. So fx, dou f by dou x, so differentiate partially with respect to x keeping y as constant, and around 3x squared plus 3y squared minus 30x plus 72. Yeah. Then fy அப்படினா so differentiate partially with respect to y keeping x as constant. But then இது 0. இதை differentiate பண்ணா 6xy and this is 0 and here minus 30y. இது 0 ஆயிரும் இல்லையா? Next fxx. So differentiate fx with respect to x. இல்லையா? அப்ப then 6x. இது 0 minus 30. And this is r. Is it right? அடுத்து fxy அப்படிங்கிறது என்னது s. இதை என்ன பண்ணணும்? fy with respect to x பண்ணணும். So இதை with respect to x பண்ணினா 6y. Next t fyy. So that means you differentiate fy with respect to y. இதை with respect to y பண்ணினா என்ன வரும்? 6x minus 30. Right? Okay. So this is a step 1. So step 2 என்ன சொல்லிருக்கேன்? Put fx equal to 0 and fy equal to 0. Step 2. So put fx equal to 0. So fx equal to 0 na and around 3x squared plus 3y squared minus 32x plus 72 equal to 0. So this is equation number 1. And fy equal to 0. Fy vandanadu, which implies 6xy minus 30y equal to 0. So this is 2 So this equation we solve. So how can we solve these two equations? So from 2 I can take 6y outside. So remaining x minus 5 equal to 0. So which implies y equal to 0 or x equal to 5. Okay. So when y equal to 0, so equation 1 when y equal to 0, equation 1 becomes y equal to 0 substitute pannina 3x squared is 0 minus 30x plus 72 equal to 0. 3 divide pannina x squared minus 10x plus 2 3s are 6 24. So product panna 24, add panna 10. So 6 4s are clear. So x minus 4 into x minus 6 equal to 0. So x equal to 4 or x equal to 6. So therefore the points are 4, x or y equal to 0 are x 4 kadichirukku. So 4, 0 or 6, 0. Right? When x equal to 5, equation 1 becomes x equal to 5 in substitute pondering. Now 25 into 3, 75. Is it right? Plus 3y squared minus 30 into 5, 150 plus 72 equal to 0. Simply upon 147, right? So 3y squared minus 3 equal to 0. So y squared equal to 1, y equal to plus or minus 1. Therefore the points are 5, 1 and 5, minus 1. Right? Therefore the stationary points are the 4 points. Points 4, 0. The stationary points are 4, 0, 6, 0, 5, 1 and 5, minus 1. Right? These are the stationary points. So at these points you have to verify that whether the function has the maximum value or minimum value. To take the first point, start 4, 0. That is a step 3. So step 3 I have to compute delta. Okay, I have to take each point, I have to find out delta and r. So delta equal to rt minus s square. What is r? 6x minus 30. You put x equal to 4. So 24 minus 30 equal to minus 6. So s equal to 6y. So 6 into 0 is equal to 0. And t, now 6x minus 30. So 6 into 4, that is 24 minus 30 minus 6. For delta order value in our rt minus s squared. So minus 6 into minus 6 minus 0 squared for 36. So greater than 0. If delta greater than 0 or less than 0, the function has a maximum value at this point. For maximum value calculate panna, you substitute in the given function. X is 4 and y is 0. You substitute here, you may get the value 112. Right? You take another point at 6, 0. What about the delta? So r equal to 6 into 6 minus 30, so which is equal to 6, and s equal to 6y, so 6 into 0 again 0, then t equal 6 into 6 minus 30, so 6. So delta oda value enna varudhu rt minus s squared, so 36 minus 0, so again 36, so positive 1. So delta greater than 0, what is r? So delta greater than 0, r is 6, so r is also greater than 0, therefore the function has a minimum value. So minimum value at this point 6, 0. So minimum value venu appadina you substitute in the given function. X equal 6, so 6 cube minus 0, 15 into 36 minus 0 plus 72 into 6. Substitute point 108 varum. That is the minimum value. Next the point at 5, 1. What about r? 6 into 5 minus 30, so r is 0, and s equal to 6y, so 6 into minus 1, so minus 6, and t equal to 6 into 5 minus 30, so 0. So it is delta rt minus s squared, so 0 minus 36, so less than 0. So delta oda value less than 0 and enna sollirukken, the function has a neither maximum nor minimum. So neither, therefore the function has neither maximum nor minimum. The next point, so at 5, minus 1, so r equal to 0, s equal to 6, t equal to 0, then delta equal to rt minus s squared. So delta equal to minus 36. Yeah, again less than 0, therefore the same. Delta is less than 0, the function has a neither maximum nor minimum. Is it right? Again the same point. The function has a neither maximum nor minimum at this point. Out of the 4 points, these 2 points has neither maximum nor minimum. So at this point the function has a maximum value, and at this point the function has a minimum value. Right? Identify the saddle point and the extremum points of the function x power 4 minus y power 4 minus 2x squared plus 2y squared. So saddle point and extremum knowledge the maximum value and minimum value now, right? So take let f equal to x power 4 minus y power 4 minus 2x squared plus 2y squared. So step 1 enna sollirken, first to identify the partial derivatives, first order and second order. So fx equal to 4x cube minus 4x, fy equal to minus 4y cube plus 4y, and fxx, so that is r equal to 12x squared minus 4, and s equal to fxy is nothing but a differentiate with respect to x, so 0, and t equal to fyy, differentiate with respect to y, so minus 12y squared plus 4. Step 2, so put fx equal to 0 and fy equal to 0. So fx equal to 0 and 4x cube minus 4x equal to 0. You take 4x outside. So x squared minus 1 equal to 0. So x equal to 0 or x equal to plus or minus 1. Then fy equal to 0 implies minus 4y cube plus 4y equal to 0. You take minus 4y outside. So y square minus 1 equal to 0. Therefore y equal to 0 or y equal plus or minus 1. So this is 1 and this is 2. So when x equal to 0, y equal to 0 and y equal to plus or minus 1, and similarly vice versa. Therefore the stationary points are straddle points. Stationary points and saddle points are one of the same, right? Therefore the stationary points or saddle points are when x equal to 0, so y equal to 0, and x equal to 0, y equal to 1 and minus 1. When x equal to 1, y equal to 1. When x equal to minus 1, y equal to 1. When x equal to minus 1, y equal to 1. Then x equal to 1, y equal to minus 1. And x equal to minus 1, y equal to minus 1. So these are all the stationary points. Okay. So another one, when y equal to 0, when x equal to 1 and minus 1, right? So therefore 1 comma 0 and minus 1 comma 0. So these are all the saddle points of this function, right? So you find out, you take each and every point and substitute in this third step. What is the third step? Compute delta. So delta equals RT minus A square. We take each and every point and compute this value delta, and we check whether R is greater than 0 or is less than 0. You may get the value. To compute delta equal to RT minus S square for all these points, we verify that at the points 0, 0, 1, comma minus 1, 1, comma 1, minus 1, comma 1 and minus 1, comma minus 1, the delta value is less than 0. If delta is less than 0, the function has neither maximum nor minimum, right? So at the points 1, comma 0 and minus 1, comma 0, delta is greater than 0 and R is greater than 0. Therefore the function has a minimum at these points. Therefore the minimum value is minus 1. Next at the 0, comma 1 and 0, comma minus 1, again delta greater than 0 and R is less than 0. Therefore the function has a maximum value at these points. Therefore the maximum value is 1, right? You try these three problems. Okay, so examine the function f of x comma y, x cube y square into 12 minus x minus y for extreme values. Next problem, f of x comma y equal to x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square. And third problem, f of x comma y equal to x square plus xy plus y square plus 1 by x plus 1 by y.